In this video, I'm going to talk about properties of continuous function. But before that, let me remind you what does it mean for a function to be continuous at a point. So let's say we have a function f and it's continuous at point A. By definition, this means that limit x approaches A, f of x is actually equal to f of A. That's what it means for a function to be continuous at a particular point. So please note that here to define continuity, we introduce the concept of limit. So the continuity kind of derives from the definition or application of limit. So it may naturally or intuitively make sense whatever the properties of limits are may also be the properties of continuous functions. So there must be a similarity or continuity between these two because we defined continuity from limit. So let's go ahead and kind of see what happens. So let's consider two functions f and g, and they happen to be continuous at point, let's call it A, and also we are going to make an assumption that we have another constant, a real number c. If that is the case, the following properties hold true. Number one, if f and g are continuous at this point A, so is f plus g. And by the way, so is f minus g. So that's property one. Number two, f times constant or c times f is also continuous at point A. Number three, f times g, the product of these two functions, continuous functions, is also continuous at the point. And finally, the ratio of these two functions, f over g, is also continuous at the point of interest, which is A. Only exception here is that you have to make sure that g of A is not equal to 0. Now let me go ahead and prove just one of the properties, and the others you can easily derive. So let's kind of prove that if f and g are continuous at a point, so is f plus g. All right. So let's use the definition of continuity, right? What does it mean for a function f plus g to be continuous at a point A? So by definition, it's going to be limit x approaches the value A, f plus g of x. Okay, that must be equal to limit x approaches A, right? F of x plus g of x. That's what it is. Just on a side note, just to remind you, when we say we take the sum of two functions, f plus g of x, we define it, or what this means is actually this is f of x plus g of x. That's what it means. We just write it in this notation. So by applying this definition or by applying this convention, we can rewrite this function as f of x plus g of x. Now, limit of sum of two functions is the sum of the limits, right? We are applying the properties of limits. So this, I could break it down into two pieces. So limit x approaches A, f of x, plus limit x approaches A, g of x, right? Now, by the way, it is already given that the function f is continuous at point A. So that means by definition of continuity, this must be equal to f of A plus, for g is going to be g of A. So we just showed that if f and g are continuous functions, then so is f plus g. That means f plus limit x approaches A, f plus g of x must be equal to f of A plus g of A. Similarly, just using the minus sign, you could do the minus, right? So that takes care of this. For multiplication by constant, again, you are just multiplying f by a constant c. Now, if you take the limit, c is not going to be impacted by the limit. So therefore, this should be pretty straightforward. F times g, you can do it easily. The product, you remember the limit rule? Limit of the product is the product of the limit, so you could use that property. And for ratio or the division, f over g, again assuming that g of a is not equal to 0, we could apply the property of limits and come to the conclusion that f over g is also continuous, given that f and g are continuous at a particular point. I hope that this discussion was helpful. Thank you so very much.